Hello, my name is Justin Martin, and I am a student in the Department of Computer Science at the University of Nevada, Las Vegas. I am here today to present my research for CS301. I will be exploring data privacy risks in 5G IoT technology. I will first provide a little introduction with some background information on 5G and Internet of Things devices. I will then discuss how 5G and IoT create a perfect union to help deliver their benefits to several industries. I will then acknowledge some of the risks associated with each of these technologies and the combined risk of incorporating both technologies. Then I will provide some potential solutions to these problems, current legislation, and my final thoughts. Privacy is valued by almost everyone. Daniel Solov, a professor of law at the George Washington University Law School, says that privacy is the most comprehensive of rights and the right most valued by civilized men. Since the inception of computer technology, privacy has always been a major area of concern, especially now that we have so many devices that collect data on us. That data is sold and utilized to provide us personalized experiences, whether it be through ads or adjusting an application that we use more efficiently. Using these technologies put our information at risk, even if it provides a little convenience in our lives. With the development of 5G, we can expect a wave of new Internet of Things devices, as new applications that weren't possible before with 4G are now possible with 5G. Qualcomm, a world leader in 5G intellectual property, sees 5G as a network built for connectivity. Its faster speeds, lower latency, and higher bandwidth are all built in mind for IoT devices. 5G networks will enable device-to-device communication unlike never before. However, this also means that they will be collecting more and communicating more data over the network, and this can be worrying. 5G is still in its early stages, and its standard could change in the future, similar to 4G's evolution to 4G LTE. As mentioned before, the main features of 5G is multi-device connectivity, higher speeds, and lower latency. This is achieved through the use of higher bandwaves, but also through new network technologies, such as network slicing using SDN and NFV techniques. Network slices allow for multiple virtual networks on one physical network. This allows for groups of similar devices to communicate in one layer, allowing for the management of resources to be more efficient and for many more devices to connect to the physical network. As these devices communicate with each other, they are expected to transmit large amounts of data. 5G base stations are equipped with cloud computing environments to help process this data in real time. These features can impact major industries such as healthcare or smart cities where data from every aspect needs to be put together and analyzed quickly. Another feature of 5G is that it is built on top of 4G LTE infrastructures, as it utilizes much of the same encodings. This allows for greater compatibility as both networks can coexist using DSS technology. This also means 5G will not be replacing 4G anytime soon. The Internet of Things are devices that have varying connections and communication protocols. There is not a single standard, and manufacturers can utilize any protocol they choose. However, IoT devices are meant to be connected nonetheless. Together, they gather and transmit data to provide details of a larger picture. This data is processed to hopefully improve efficiency and tailor user experience. We already have an abundance of these devices such as smart thermostats, voice assistants, or any other type of sensor. Before 5G IoT devices were very limited to the low bandwidth speeds and high latency of 4G networks. 5G is essentially creating the perfect environment for IoT devices to collect and process data remotely in real time. Because of these faster speeds and higher bandwidth, it is likely that we will see more data being communicated between devices as it is more reliable. This can be beneficial in situations such as remote surgery, where a doctor needs really low latency and very accurate information to perform on the patient. Self-driving cars are another application, as they can communicate with each other and transmit data to the cloud to be processed in real time. That way, they can make decisions much faster and much smarter. Although this sounds way more convenient than life today, the amount of information being retrieved and processed will increase enormously. And that is worrying because there will be much more at stake. Therefore, it is important to make sure this technology is safe before full implementation is achieved. Researchers at the Berlin Institute of Technology have already discovered some vulnerabilities that are present in 5G systems because it was designed on top of 4G. The underlying cause seems to be that the current tech does not establish security before access to the network. This also means there is a lack of verification, and this could lead to a data breach to the devices on the network. There is also an issue with the network slices. SDN and NFV allow for slices to be flexible and open for the compatibility of devices, but that also leaves its security weak, allowing for misuse of the SDN controller. Lastly, 5G cloud computing stores a lot of data on the network, and this can be bad if the network is ever compromised. IoT devices are even worse, as there is a lack of standardization. Many IoT devices have insecure radio interfaces and lack the ability to protect data integrity. If just one IoT device is compromised, then all the devices on the network are compromised. These issues are exacerbated when we pair 5G with IoT devices, as faster speeds and better connectivity will facilitate these issues much better. A potential solution is using blockchain technology, which will decentralize the network, making all data communication anonymous and secure with authentication and distributed ledgers. The downside to this is that it can make communication between devices much slower. In order to solve the issues with the 5G network, there needs to be more secured verification and authentication techniques. To fix IoT devices, there needs to be a more secure and consistent standard. These devices will also need to stay up to date all the time. Current legislation aims to improve cybersecurity with 5G IoT devices, such as the IoT Cybersecurity Improvement Act of 2020. This act required the National Institute of Standards and Technology and the Office of Management and Budget to increase efforts of cybersecurity for IoT devices within the government. NIST is to publish these guidelines to help agencies better utilize IoT devices. However, there is nothing for consumer and private sector use. This act only benefits the government, but we are hoping the publications are visible and beneficial for societal use. In conclusion, 5G and IoT devices have the potential to revolutionize every aspect of our lives, as it enables for more data collection and faster processing of that data. We provide better personalized experiences and much more efficient applications. However, this comes at a high risk to our data and privacy. More research and development are needed to incorporate secure technologies and protocols within 5G and IoT devices. Current loopholes with both technologies also need to be addressed. There is hope that the government can help propagate these standardizations through legislation and encourage the advancement of 5G IoT technology. Thank you, and that concludes my presentation.